DeepSeek might have just exposed its next flagship model on GitHub, and it looks huge. Zhipu launched a long-context MOE model built for real coding and reasoning. Japan just revealed emotion computing AI based on body signals. And Nous Research dropped a competitive programming monster that learns by running code and getting punished for failure. Alright, let's start with the most suspicious story of the week, DeepSeek. This one isn't an official product announcement. It's basically developers catching DeepSeek, leaving evidence of what they're building next. And when the evidence comes from code, it's always more serious, because companies can control press releases, yet code changes tend to expose what's actually happening internally. On January 21st, 2026, new information surfaced suggesting that DeepSeek may unveil its next flagship AI model, DeepSeek V4, and the timing that people are guessing is mid-February, around the Lunar New Year period. The biggest expectation? A large jump in coding ability. So where is that coming from? On January 20th, which also happens to be the first anniversary of DeepSeek R1, developers noticed DeepSeek updated a large batch of Flash MLA code on GitHub, and it wasn't like 1 or 2 files. It was massive. 114 files were changed. Inside those updates, developers started seeing this unknown model identifier, MODEL1, and it appears 28 times. Obviously, that's not some placeholder somebody forgot to delete. It's repeated enough times that it clearly refers to something real. What makes it even more important is that this MODEL1 label shows up alongside another model identifier called V32, which refers to DeepSeek V3.2. And in some places, the code explicitly separates MODEL1 from V32, meaning MODEL1 is not treated like a normal minor version bump. That immediately triggered the bigger question. Is DeepSeek building a completely new flagship on a new architecture rather than just iterating on V3? The developer analysis started noticing technical differences between MODEL1 and V32 in a few key areas. And these are the kinds of areas that point to deep changes under the hood, not surface-level improvements. One is KV cache layout. KV cache is basically the memory structure that makes modern transformer inference efficient. It's what allows models to keep track of context without reprocessing everything from scratch. If DeepSeek is changing KV cache layout, it means they're redesigning how the model stores and retrieves information during generation. And that's usually tied to performance, memory efficiency, and speed, especially in long context. The second thing is sparsity handling. If there are differences in how sparsity is handled, that's often a sign of compute efficiency tricks. The whole idea of sparsity in AI models is that not everything needs to be fully active all the time. You can skip parts, reduce compute, speed things up, and still keep quality high if you do it right. And the third thing is FP8 decoding support. FP8 is about squeezing performance out of modern hardware, lowering memory, increasing throughput, and making huge models practical. If their new system is explicitly built around FP8 decoding support, that tells you this model is being engineered for efficiency at scale, not just raw intelligence. So, when you combine these signals, KV cache redesign, sparsity differences, and FP8 decoding support, it looks less like DeepSeek V3.3 and more like DeepSeek is building something structurally new. And this aligns perfectly with DeepSeek's recent research direction too. DeepSeek previously released 2 technical papers, one about a new training method called Modified Hierarchical Connections, or MHC, and another about a biologically inspired AI memory module called Engram. So, now people are speculating that V4 could be the first DeepSeek flagship model to actually integrate these research directions, new training structure through MHC, and memory behavior through Engram. That's where the whispers of a redesigned architecture become even more believable, because you don't publish research like that unless you're planning to deploy it into a real system. DeepSeek still hasn't confirmed anything officially, yet the code is basically screaming that something new is being prepared. And if the rumored Lunar New Year mid-February timeline is accurate, we're not talking about a distant future release. We're talking about something already in the final stretch. Alright, now, we cover big AI breakthroughs here, but the real shift is tools people can actually use. AI 3D is moving fast, and most tools look good until you rotate the model and it falls apart. This one actually holds up. It's called Hitem 3D, and they're sponsoring today's video. Hitem 3D generates textures in a structure-aware way, so details feel built into the geometry, not pasted on. It can fill in unseen areas like undersides and interiors, and it reduces baked-in lighting for cleaner, more consistent materials, great for PBR, and 3D printing. There's also a portrait mode that keeps character details like hair and faces sharp. Bottom line, Hitem 3D2 is built for real workflows, game assets, product concepts, prototyping, and 3D printing where usable output actually matters. You can try it with a free test, and the link's in the description. All right, now back to the video. Now, right after that, we jump to China again, but this time it's not rumors. It's an actual model release from Zhipu AI. So, Zhipu AI, also known as Z.AI, just released a model called GLM 4.7 Flash. And this one is very targeted. It's built for people who want something strong at reasoning and coding while still being realistic to run locally, so you can actually deploy it in your own workflow without needing some massive GPU cluster. And that matters a lot more than people admit, because most best-in-class AI models right now are either too expensive to run, too heavy to host, or locked behind paid APIs. GLM 4.7 Flash is described as a 30 BA 3B MOE model. That sounds technical, so let's translate it into normal human language. It means the model has around 31 billion total parameters, yet it doesn't use all of them every time it generates a token. It's built using an architecture called Mixture of Experts. In Zhipu's case, they say the model is a text generation model with 31B parameters. It supports English and Chinese, and it's configured for chat and conversational use, not only raw completion. It uses an architecture tag called GLM 4_Mo_Lite, and it sits inside the wider GLM 4.7 family, right next to GLM 4.7 and GLM 4.7 FP8. And here's a key detail. ZAI positions GLM 4.7 Flash as the lightweight and even free tier option compared to their full GLM 4.7 model, while still targeting serious tasks like coding, reasoning, and agent workflows. In other words, it's meant for the people who can't deploy something in the 358B class, but still want something that plays in the same modern league. Now, one of the biggest reasons this model is relevant is context length. GLM 4.7 Flash supports 128,000 tokens of context. And it uses a standard interface and a chat template, which makes it easier to integrate into existing AI tools without rewriting your whole pipeline. Now, benchmarks matter too, because every model claims it's amazing. So ZAI compares GLM 4.7 Flash against other models in the same category, like Qwen 330, BA3B Thinking 257, and GPT OSS 20B. Their claim is GLM 4.7 Flash leads or stays competitive across math, reasoning, long horizon benchmarks, and coding agent tests. For most tasks, their default settings are temperature 1.0, top P 0.95, and max new tokens 131,072. That means the model is allowed to generate huge outputs and it's not forced into short answers. For Terminal Bench and SWE Bench Verified, they use temperature 0.7, top P 1.0, and max new tokens 16,384. For Tau Squared Bench, they go even stricter. Temperature 0 and max new tokens 16,384. Basically, if the task needs precision and stable step-by-step tool usage, they reduce randomness. They also recommend enabling something called Preserved Thinking Mode for multi-turn agent tasks like Tau Squared Bench and Terminal Bench 2. The idea is that the model preserves its internal reasoning across turns, which matters when you're building agents that need long chains of actions, corrections, and function calls. And finally, they point out that GLM 4.7 Flash supports VLLM, SGLang, and transformers-based inference. And there's already a growing ecosystem of fine-tunes and quantizations, including MLX conversions on Hugging Face. So that's Zhipu's move. Strong coding and reasoning, MOE efficiency, long context, and actually deployable. Now, let's shift away from models and rumors and move into research that sounds almost sci-fi, emotion computation. A research team in Japan just released a new AI framework designed to model how emotions form, not as some magical feelings engine, but as a computational process tied to the body. This research comes from Assistant Professor Chi Hieda from Nara Institute of Science and Technology, NAIST, working with Assistant Professor Kazuki Miyazawa, and then Master's student Kazuki Tsurumaki from Osaka University. The study was made available online July 3, 2025, and later published in IEEE Transactions on Effective Computing, Volume 16, Issue 4, on December 3, 2025. So this isn't an early concept post. It's fully published research. The whole model is based on the theory of constructed emotion. This theory says emotions are not simply hardwired reactions. They're concepts built by the brain in real time, by combining internal bodily signals with external sensory information. Internal signals are interoception, like heart rate. External signals are exteroception, like what you see or hear. The researchers explain that while theories like this exist, the actual computational process behind emotion concept formation has not been explored enough. So what did they do? They built a computational model using multi-layered multimodal latent Dirichlet allocation called mMLDA. mMLDA is basically a probabilistic generative model that discovers hidden patterns and categories by looking at how different data types occur together without being told explicit labels. So the model is not trained on this is fear, this is joy, or this is sadness. It learns from patterns. They trained it using unlabeled data from human participants watching emotion-evoking content like images and videos. The system wasn't informed what emotion each thing was supposed to represent. It had to discover the categories on its own. They collected real human data. 29 participants viewed 60 images from the International Affective Picture System, a standard dataset in psychological research. While participants viewed these images, researchers recorded physiological responses like heart rate using wearable sensors and also collected verbal descriptions. So you basically get 3 layers of data: visual input, physiological response, and language. Then they compared what the model learned against participants' self-reported emotional evaluations. And here's the headline number: about 75% agreement. That's way above chance, which suggests that the model's discovered emotion categories align strongly with how people actually experience the emotions. And the practical implication here is surprisingly big. This kind of AI could be integrated into emotion-aware robots and assistants. It could allow AI to respond in more context-sensitive ways based on what someone is experiencing, not just what they're typing. They even mention that because the model can infer emotional states people struggle to express in words, it could be useful in mental health support, healthcare monitoring, and assistive technologies for conditions like developmental disorders or dementia. So yeah, this is not AI feels. This is AI understands emotional experience patterns. Now let's close with the most hardcore part of this whole set, Nous 14B. Nous Research just released Nous 14B, and this is basically an AI that's trained for the most difficult type of coding you can test: competitive programming. The kind of coding where there's a huge set of hidden tests, strict time limits, strict memory limits, and if your solution is even slightly wrong, you fail. No mercy. They built it on top of Qwen 314B, then improved it using reinforcement learning. And in plain language, that means they trained it like this. The model writes code, then the code is actually run in a sandbox, and it only gets rewarded if the program truly works. So, it's not learning to talk like a programmer, it's learning to survive real test cases, and the results show it. On LiveCodeBench v6, which contains 454 competitive programming problems and covers tasks from August 1st, 2024 to May 1st, 2025, Nous 14B reaches 67.87% pass at 1. And pass at 1 is the toughest version of scoring, because it means the first answer the model gives has to be correct. One shot. The base model, Qwen 314B, scores 60.79% on the same test. So this training boosted it by 7.08 percentage points, which is a serious jump in a benchmark like this. They trained it on 24,000 verified coding problems, using 48 NVIDIA B200 GPUs for 4 days. And they released it under the Apache 2.0 license on Hugging Face, so it's actually usable for real projects. Now, the way they trained it is honestly the coolest part, because it's very different from normal AI training. Each time the model generates a solution, that code gets executed. If it passes every hidden test, it gets a reward of +1. If it fails, or takes longer than 15 seconds, or uses more than 4 GB of memory, it gets hit with -1. That's it. Simple and brutal. To do this safely, they run the code inside isolated containers using MODEL1, so nothing can break the system. And they also optimized how they test things. Instead of wasting time running every single test, they prioritize the hardest test cases first. And if the solution fails early, they stop immediately. That makes the whole training pipeline faster and more efficient. On the training side, they tested multiple ways of doing reinforcement learning, GRPO as the base method, then 3 objective variants called DAPO, GSPO, and GSPO+. You don't really need to memorize those names. The point is they tried different learning recipes to see what works best. At a very long context, length of 81,920 tokens, DAPO performs best with 67.87%. Pass at 1, while GSPO scores 66.26% and GSPO Plus scores 66.52%. At 40,960 tokens context length, they all land around 63%. They also train the model to handle long prompts in stages. First at 32K context, then 40K, and later they extend it at evaluation time to about 80K using Yara and context extension, reaching 81,920 tokens. And there's one more smart detail. If the model generates something too long that goes beyond the maximum context window, they don't punish it. They just ignore it by setting its advantage to 0. That prevents the model from learning shortcuts like forcing short answers just to avoid penalties. Alright, that's it for today. If you want more AI breakthroughs like this, subscribe and drop a like. Thanks for watching, and I'll catch you in the next one.